Good Wednesday to you again, everybody in Gov 603. Welcome back to week 13 and our review of week 12. Okay, let's see what you did while I was got a hair on my nose or something, probably mine, and check out your answers to the questions. Okay. Week 12, question number 1. What is a dummy variable? How is it created? Why would a researcher use it? Either post an example in your response or link to an example. Okay. So I sent you a little video and, extra points to you if you could follow along with the presenter's accent as to what a dummy variable is. Okay. Please do not say it's a variable that makes no sense whenever you're asked. All right. But Michael, you know what? Actually, Stephanie, let's take a look at, no, I'm sorry. Maya, let's take a look at what you're doing here. Okay. Dummy variable, sometimes called indicator variable, helps researchers utilize categorical variables as predictor variables in regression analysis. Now, that is absolutely correct, but remember, I need you to be able, in your own head, to translate that into English so it makes sense to you, okay? Dummy variables are numeric variables used in regression analysis to represent categorical data that can only take on one or two values, either 0 or 1. That's true. Or actually, and the value is anything you assign it. It can be 1 or 2 or 2 or 3 or 0, 1 or, or A or B. Okay. The formula creating dummy variable is K1, where K represents the number of different values categorical. Okay. So let's try that's exactly right. And people, folks look down at Maya's, the tables that she includes there. So let's say you want to do a t-test. Okay. Now remember what a t-test does. A t-test measures if there's a statistically significant difference in the averages of two different things. Either two things doing the same thing, okay, or two different things, or so yeah, two different things doing the same thing, or two different things, or two same things doing different things. So, for example, let's say in an example that they give you, it's cars. Okay, so let's say you wanted to compare the speed of trucks versus other cars. And you sat on the side of the road and you watched when you had a little speed, tracker in your hand. And when a truck went by, you pointed at it and you took its speed and you wrote it down. And then when a car went by, you took its speed and you wrote it down. But then a van goes by and you take its speed and you write it down. And then an SUV goes by and you take its speed and you write it down. And then another truck goes by and so on and so forth. So at the end of the day, you have speeds recorded from trucks and speeds recorded from a whole bunch of different other cars. 2 doors, 4 doors, minivans, SUVs, electric Priuses, all of this stuff. Okay, but you are only interested in the average speed of trucks and if it's statistically significant in terms of the average speed of non-trucks. So you create what's called a dummy variable. Okay. So you say, you can use binary, but 1 and 0 are traditional. So you say everything that was a truck gets assigned the number 1. Anything that is not a truck gets assigned the number 0. Okay. Like that. All right. Now, within that category, that you've assigned the number 0 to. That holds everything that's not a truck: cars, minivans, SUVs, little Priuses, motorcycles, everything that is not a truck. That assigned category, and you just give it the number 0, and then you can run a t-test because you're recording the speeds, and you say, what's the average speed of all the vehicles? I've given the number 0, and remember, 0 doesn't mean there's no vehicles in that category. That's just a designator. You could give it the number 2 and call all trucks 3. It doesn't matter as long as you just have 2 numbers, this category and that category. And then when you run your t-test, you take the average speed from all of those vehicles in that category, in this case that we've assigned the number 0, and you run the calculations and you say the average speed of all the vehicles in this category 0 is whatever the average speed is, and the average speed of all the vehicles in category 1, which we call trucks, is whatever it is, and then you can compare the two. That is a dummy variable. The dummy variable is you assigning this category of 0 or 1 and then dividing up all of the things that you want to study into these 2 categories: the thing category, the truck category, and then everything that isn't that. That's a dummy variable. Do you understand? And if you don't, make sure that you reach out to me. Okay. This application is very, very common in empirical research. So if you're reading along in an article and you say, and we created dummy variables, because let's bring it back into political science. Let's say you were interested in voters and you wanted to poll them concerning I'm just making something up here, concerning how worried they are about the deficit. All right. But you were going to say, what we're going to do is we want to find out, you could just in a descriptive way, just the average. On average, how worried are those who identify as Democrats about the deficit compared to anybody else? So you create 2 categories. One category, you put all the people that you talk to, you phone them up in your survey, say, hi, I'm doing a survey and we're trying to find out how worried you are about the deficit. And oh yeah, I'm really worried. Yeah, blah, 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 blah. And you say, oh, okay, are you a registered Democrat? And they say, yes. You put them into that category that you assign the number 1. And then you call up some more people. You say, hi, I'm doing a survey, blah, 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 blah. Are you worried about the deficit? And they're like, oh, I'm terribly worried about the deficit, blah, blah, blah. And you say, oh, okay, are you a registered Democrat? And they say, no, I'm registered with the Green Party. And you go, oh, okay. You put that person, their opinion, into the second category that you created, represented by whatever number you want to assign to it, right? The creation of those categories, that's the dummy variable. Got it? Okay. Question number 2. All right. Since we're talking about categorical variables and creating them, what is a categorical variable? Okay. And now remember what I've told you, that the difference between variables or types of empirical research, be it quantitative or qualitative, is simply an expression. It's a matter. It's a representation of how you go about doing the research. Data is data. It's not like there's some kind of data like there are pens and there's other kinds of data like there are pencils. No, information is information. How you decide you want to record it as a researcher turns it into either a qualitative report or a quantitative report. So what is a categorical variable? Felix, let's look at you. A categorical variable is a type of variable that has a value defined from a collection of categories that allow no others to and are non-numerical. Okay. Well, they can be numerical, but okay. So again, that is correct. But remember what I want you to be able to do. I want you to be able to translate this into English. All right. In your own head. So if that does not make sense, because I see a lot of you are just kind of copying and pasting, all right, I want you to make sure that it makes sense. So Ashley, let's look at you. A categorical variable, as its name implies, is a variable that can divide observations into various classes or categories without any numerical relationship between them. Exactly right. Okay, exactly right. For example, eye color. That's a categorical a categorical variable. Okay. Height can be a categorical variable because there's nothing sequential. Let's say you have a bunch of people. We want to say, what's the average height of people who eat, I don't know, lots of spinach? So you go out and into the public, you find a bunch of people who are spinach eaters, and you say, okay, so you don't drive yourself mad. You say, I'm going to create 5 categories because you're studying, let's say, people who are 18 and up. Okay, 5'5" to 5'7", 5'8" to 5'10", 5'11" to 6'1", 6'2" to 6'4", going in 2-inch increments. Okay, 6'5" to 6'7", big person. All right. Now you measure the people. Now let's say someone is 5'6", they go into that first category. Let's say someone is 6'3", they go into the 5th category. That's a categorical variable. It's a way to express what you measure. Okay? Does that make sense? All right. On the other hand, what is a continuous variable? Okay. So within recording data, these are the 2 major types of data: categorical data, continuous data. So we call them categorical variables, continuous variables. What is that? Susan, let's look at you. A continuous variable is a variable that takes numerical values that can be arbitrarily close to each other, represented by numbers with decimals or fractional parts. That's true. Okay. But again, I want you to be able to translate that in your head. One of these examples would be temperature. There are so many temperatures, it seems that temperatures would theoretically never end in either direction. Okay. Excellent. Okay. So continuous variables can be things like temperature. They can be things like how much money do you make? Because theoretically, there's no limit. I mean, practically there is, but theoretically, there's no limit to up and then all the way down to 0. They go on and on and on and on in a category. Okay. Now, there's a way to record data that creates a categorical, a continuous variable that's commonly used in research, that I want you to understand when you see this. Okay, because you might go, oh, wait a minute, that aren't which isn't that what you're doing? Isn't this person doing categories? Okay, not exactly. Let's see, and I'm just writing on my magic pad here. Okay. This is extremely common in empirical research. It's called the Likert, L-I-K-E-R, Likert scale. And it's always an odd number, so 1 through 5 or 1 through 7 or 1 through 9 or whatever, usually 1 through 5 because that's straightforward. And it goes like this. You'll see a survey and it'll say, please respond to the following statement. Okay. President Biden is doing a good job as president. And then it'll give you 5 numbers with responses next to them. And it's traditionally the way this is set up. Number 1 is strongly disagree. I've just written SD. Strongly disagree. Number 2, disagree. Number 3, no answer, no opinion. I don't know if he's a good president or not. Okay. Number 4, agree. Number 5, strongly agree. Now, although you have set up categories, 1, 2, 3, 4, 5, okay, that what you're measuring is the continuous flow of someone's emotions, someone's opinion. Okay, so we call the Likert scale. This produces continuous data, continuous variables, and this kind of scale is extremely common in empirical research, especially in political research, to try to get someone's opinion into the form of a continuous variable. Okay. Question number 4. Look online and find an example of regression analysis with categorical variables. Post it. Explain what's being analyzed. Okay, that one I'm just going to leave to you because that one is very, very straightforward. You know, you find it or you don't. And this is one of those ones where it's like, okay, I'm just making sure that you understand what this is. And so, by the way, if you know, for the final exam, you might see the expression of a study, the outcome, and I would ask you, is this, true or false? Is this an example of a regression analysis? Okay. And that would be up to you. Okay. That's question number 4, and we're not going to, I'm not going to read your answer. Okay. Did I skip question number 1? No, I didn't. That's dummy variable. Okay. All right. So if you're having any issues wrapping your head around these definitions and being able to pick them out, call me during my office hours or email me. Okay. I don't want, the one thing in this class that I'm not asking you to try to figure out is what it is I want you to try to figure out. All right. Okay, everybody, have a fantastic week. I will be in my office on Friday, as well as I am. My office hour is done now for today. And I will see you on campus. All right. Take care. Bye-bye.